Hello everyone, in this video we are going to discuss about holography. As you all know that in photography we get a two-dimensional image of an object, of a three-dimensional object, but in holography we get a three-dimensional image of a three-dimensional object. Now holography is a two-step lensless imaging process. Now this theory was developed in the year 1947 by a scientist named Dennis Geber, and for this he won the Nobel Prize in the year 1971. The word holography comes from the two Greek words. So I have written hologram here, it will be holography. So the first word is holos and the second one is graphene. So holos means whole, whereas graphene means to write. So holography means writing the complete image. So in holography actually there is a recording of interference pattern which is formed by two coherent light coming from the same source. So here in this process both the amplitude and the phase information of the light coming from the object is recorded on a photographic plate, and that plate is known as the hologram. Now holography is a two-step process. First is the recording of the hologram. So this method requires highly coherent light. We have used laser beam here which is highly coherent. Now it is incident, this light is incident on a beam splitter. Now this beam splitter divides the laser beam into two parts. The first is the reference wave and the second is the object wave. The reference wave is first incident on a mirror, and from there it directly falls on the photographic plate. This photographic plate is known as the hologram. Therefore the reference beam goes directly to the photographic plate or directly goes to the hologram. The second wave, which is the object wave, is first incident on a mirror, and from that mirror it is directed to the object. From there it becomes the object wave, and from this object wave it directly goes to the hologram. In this way the laser beam produces two beams, that is the object beam and the reference beam. Now since they are originated from the same laser, therefore they are coherent and they interfere and form the interference fringes on the plane of the photographic plate. Therefore the photographic plate which carries this information, this interference pattern, is known as the hologram. This hologram does not contain any distinct image of the object, but it carries the record of both the intensity and the relative phase of the light waves at each point. Next we will discuss the reconstruction of the image from the hologram. Like an ordinary photograph plate, the hologram can also be developed. Now this hologram contains the interference pattern and the information of the object. Now that means it has the information, phase information as well as the intensity information of the object, but this is illuminated by a coherent laser beam which has the same wavelength of the original laser beam, which is known as the reconstructive wave or reference wave, and sometimes it is also known as the readout wave. Now this wave interacts with the interference pattern recorded on the hologram. Therefore the hologram, it acts as a diffraction grating and it produces two sets of diffracted waves. The diffracted waves that carries the same phase and the amplitude of the object, they interfere and reconstruct a full three-dimensional virtual image of the object behind the hologram at the original position of the object. But the other diffracted waves, they form the real image. The real image is formed in front of the hologram and the virtual image is formed at the back of the hologram. Observer can see this virtual image of the hologram is only for viewing. So if the observer moves it to different position, it looks around the image, so to some extent it will look like the real object. Remember that the virtual image of the hologram is only for viewing. This is how the reconstruction of the image from the hologram is done. Now let us discuss the comparison between photography and holography. In photography we get a two-dimensional image of the three-dimensional object, whereas in holography we get a three-dimensional image of the three-dimensional object. In photography we only record the intensity variation, whereas in holography we can record the intensity and the phase variation. In photography the recorded frame is known as the photograph, whereas in holography it is known as hologram. Now if a photograph is cut into pieces, each piece cannot give us the full information, it gives only the partial information, whereas in holography if we cut it into pieces, each piece can give the full information of the object.